This screencast refines the DistWoo model from the previous video using a RadFrac model in Aspen Plus software. RadFrac is a more rigorous simulator block that can model absorbers, strippers, extractive distillation, azeotropic distillation, and reactive distillation. RadFrac can also handle highly non-ideal components and can have multiple feed and product streams. Furthermore, RadFrac can differentially simulate a column with trays, random packing, or structured packing. In this screencast, we are going to use the parameters Aspen gave us for the DistWoo model and refine them with the RadFrac model. To begin, open your DistWoo simulation and go to the main flowsheet. Click on the column block and delete it. Create a RadFrac model in its place and reconnect the feed and product streams. Press the blue next arrow to enter information about the column. The calculation type will remain equilibrium. Input the number of stages from the previous simulation, 9. Choose a total condenser from the drop-down menu. The reboiler will remain as a kettle reboiler. Specify the distillate flow rate as 1,675.15 pound-moles per hour and a reflux ratio of 0.61. Both of these parameters were determined in the DistWoo simulation. Pressing the blue next arrow brings you to the Streams tab. Recall from the DistWoo simulation that the feed stage is 5.57. Distillation columns have the first stage at the top of the column and the nth stage at the bottom. Therefore, we want to specify the feed enters above stage 5. Next, input the condenser pressure of 1 atmosphere or 14.7 psi. The RadFrac model allows you to specify information about the trays, so Aspen can compute the column diameter and profile. Under Column on the menu tree, click on the Column Internals subfolder. Click on Add New and then open the INT1 subfolder. Click on Add New again and enter the starting stage as 2 and the ending stage as 8. The first stage is the condenser and the 9th stage is the reboiler. A message will appear asking if you would like to run a simulation to calculate hydraulic data. Click on Generate, choose the tray type as bubble cap, and leave the tray spacing as 2 feet. Click View and then the Design Parameters tab to check your assumptions. The approach to flooding is acceptable between 75 and 85%. The minimum downcomer area as a fraction of the total tray area should be between 0.1 and 0.2. The foaming factor is typically 1 for distillation columns. When all the information is inputted, run the simulation. Click on the stream summary and compare the results to the DistWoo model. Under the column results block, note the condenser and reboiler heat duties. This also provides a mass balance and the split fraction of methanol and water. Notice how the distillate recovery is less for both components. This is due to the more rigorous model which takes into consideration the non-ideal vapor-liquid equilibrium behavior between the two components. To view the column design results, click on the Results tab under CS1. Here you can view the column diameter. Click on the By Tray tab to view hydraulic results at each tray stage. To view more information about the trays, click on Geometry under CS1 and click on View Hydraulic Plots. Click on Vapor or Liquid to see the vapor or liquid rate at each stage in the column. Notice that there is no major change in the vapor flow rate above stage 5. This makes sense as the feed is entering as a saturated liquid. Alternatively, notice the large increase in liquid flow rate under stage 5 due to the state of the feed. Watch the following video on the YouTube playlist to see an application of Chapter 3 Separators to a chlorobenzene production plant. For more Aspen Plus tutorials, visit the Lafayette CHBE YouTube channel.